In today's lesson, we're going to look at your BFF for function families. For each of these functions, you either want to know the basic ordered pairs or the slope pattern. Let's look at the first function, which is a quadratic function, f of x equals x squared. We're going to put in some negatives because I know I can square negatives, so I'll start with -2, -1. I also want to see what happens to 0 when I square it, as well as 1 and 2, some positive numbers kind of going in a line. Now, I go ahead and plug in -2 into my function. That's a -2 squared. We know -2 times -2 is a +4. And then I'll input -1. -1 squared is 1. 0 squared is 0. Plug in a 1, that's positive. Square it, that's 1. And plug in 2 squared would be 4. Now those are all points I can plot on my graph. From here, it should make that parabola shape we're used to seeing for our quadratic function. So, if you would like to remember the basic ordered pairs, here they are to help you get this graph. If you would like to remember the slope pattern, that's what I like to do. Here's how I do it. I'm going to count on my graph and I'll put slope pattern down here. And I like to put quotations because the slope will change from point to point. I start at the vertex and I go up 1 over 1. So that's up 1 to the right 1. And then to get my next point, I have to go up 3, right 1. So again, I'll write that in, up 3, right 1. And then the next one, just if you're curious, would be up 5, right 1. And that can help me easily graph the right side, and I just mirror it on the left. So let's make sure we identify that's the right side. For the domain, we look all the way left to see I have an arrow that's going up and left. It has 2 directions. So the left will keep going to all those negative infinity values for x. On the right, I have an arrow that's going up as well as right. So that's going to identify I'm going all the way to the right to those positive x values infinity. You can write it in interval notation, or you can write it as the all real numbers. That's up to you. Range is going to be from 0 because I'm not going to have any negative values on my graph here for y. And it's going to keep going with those arrows up to infinity. You can use that interval notation or write it as an inequality saying everything equal to and above 0. Make sure you have a square bracket and an equal to because 0 is an included point, not an open circle. Next function is the cube function, f of x equals x cubed. I know I can cube some negative numbers, so I'm going to go ahead and start at -2, -1. I also want to see what happens when I cube 0. And I want to see what happens when I cube some positive numbers like 1 and 2. -2 cubed is -2 times a -2 times another -2. Well, that's going to come out to -8 when I calculate it. -1 cubed is going to be -1. 0 cubed is going to be 0. 1 cubed is going to be 1. And 2 cubed is going to be 8. So I'll go ahead and plot those points. Again, I might have to estimate the 8 because that's off my graph. But this gives me my cube function. To help you remember the cube function, remember you can remember those order pairs, the basic ones here that I'm highlighting. You can memorize those. Or you can memorize and use the slope pattern that's happening on the right side of your vertex. So let's look at that. I start at my vertex point, that origin point. And I see that to get to the next point, I have to go up 1 to the right 1. So that's exactly what I'm going to write in here. Then for the next point, I have to go up 1, 2, 3, 4, 5, 6, 7 over 1. So that's going to be my next slope pattern to help me graph it on the right. And what happens on the left is I just have to go down and left to help me graph the left side since it is a cube function. As you see, I have arrows at the bottom and top, as well as the left and right. So I'll have all real numbers for both the domain and range. You can write it in either interval or that fancy R, all real numbers notation. Next function up is my square root function. For this one, I know I can't input negatives or have negatives under my radical, so I'm going to start at 0 and go to positive numbers like 1. But I also know I want perfect square roots, so I think about what number I can square root to have a perfect non-decimal outcome. So I think about after 1, 4, after 4, a 9, and after 4, after 9, my 16. We go ahead and then input those x values. I have the square root of 0 being 0, the square root of 1 being 1, the square root of 4 being 2, the square root of 9 being 3, and the square root of 16 being 4. And I can go ahead and plot the points here on my graph that match the ones in my table. So remember, for this graph, you want to remember those ordered pairs here, these important ones to help you graph it every single time. If you want to remember the slope pattern for this one instead, let's find it. Again, starting at the vertex. So I look at my slope pattern here, and I see that from my vertex to the next point, I go up 1 to the right 1. And then my next pattern is going up 1, but over 3. And then after that, I would have up 1 over 5. The cool thing is this is very similar to my slope pattern of the quadratic over here. Just know instead of going up 1, 3, 5, we have to go to the right 1, 3, 5. Just cool to note. We have the domain being everything above 0, including 0, that point is filled, all the way to infinity. Just saying I can't have any x values that are not going to be negative. Can't have negative x values. We go ahead and look at the range. I again start at 0 and go to infinity. Or again, you can write it as an inequality, saying everything above greater than or equal to 0. Make sure you have the equal to, make sure you have the square bracket, because that 0 is included as a filled-in point. Cube root function, f of x equals the cube root of x. I know I can have negatives under a cube root, so I want to start with some negative numbers. But I also want perfect cube roots so I don't get those decimal y value answers. So I'm going to start at negative 8 and also include negative 1. I always want to know what happens at 0 if it's possible. And then I'll do some positive values, again, perfect cube roots, because when I take the cube root of negative 8, the perfect cube root of that is negative 2. When I take the cube root of negative 1, the perfect cube root of that is negative 1. Cube root of 0 is 0. Cube root of 1 is 1. And the cube root of 8 is 2. So I go ahead and plot those points. And again, the ones with 8 will be all the way off my graph. But this is going to be my cube root function. We go ahead and make sure to remember those crucial ordered pair points here that I'm highlighting. That's a great way to help you graph this. You also can remember the slope pattern, so let's go ahead and look about that. What's happening? And specifically on the right here. So from my vertex origin point, I go up 1 to the right 1. And then to my next point, if I'm counting correctly, I go up 1 and to the right 7. If you notice back up here for our slope pattern for the cube function, I went up 1, right 1, and up 7, right 1. So this is very similar to that. I just go up 1, right 1, and up 1, right 7. So instead of going up 1, up 7, I go right 1, right 7, just to show you how it connects. As you see on the left and right, we have arrows that are two-dimensional. So on the left, I have an arrow that's going down and left, and on the right, I have an arrow that's going up and right. Because of that, I'll have all real numbers for both my domain and range. Remember, you can write it in either notation, whichever one you prefer, I will accept. Next function we have is a fraction function. We could have negatives and fractions, so I'll go ahead and write down -2, -1. I also want to see what happens at 0, as well as 1 and 2. When I plug in -2 into this x value, and by the way, the reciprocal function is f of x equals 1 over x, that would be 1 over -2. Next one, I got 1 over -1, which simplifies to a -1. 1 over 0 is going to be our undefined answer in that calculator. Can never divide by 0. Can never have 0 in the denominator. Next one, I input x into the function. 1 divided by 1 is 1. And then last but not least, I'll input my 2. Your important ordered pair points are going to be here. Knowing that these are the ordered pair points to remember are good. We go ahead and graph this, by the way. So anytime you have an undefined, we will put a dotted line here. And then we'll graph the points of -1, -1, and up 1, 1. We're going to curve it down here. And please know that you'll have a vertical asymptote at 0 here. And we'll also have a horizontal asymptote at 0 as well, because there's no way that I'll be able to ever equal this to 0 for y, because there's no 0 ever going to be possible in that numerator. Make sure you have boomerangs kind of on each side. So talking about that, we go ahead and have our domain being everything but when x is equal to 0. Because again, we cannot do this function 1 divided by 0. That leads us to an undefined. And then we look at the range. I can have everything but y equal to 0, because there's no way 1 divided by a number will ever come out to 0. 0 would have to be in the numerator, which there's no variable or place for 0 to happen. Last of our BFF functions is going to be the absolute value function. F of x equals the absolute value of x. I really like the v in value because it helps me remember what my graph is going to look like, which is going to be a v-shaped graph. So I go ahead and start with some negative values, because remember, I can have negatives in an absolute value. I also always want to see what happens at 0. And I'll do some positive values like 1 and 2. Well, when I input a -2 into that absolute value, I know it will always come out to be a +2 because it's talking about the distance that value is away from 0. When I plug in -1, I'll get +1. When I plug in 0, the absolute value of 0 is 0. When I plug in 1, the absolute value of 1 is 1. And when I plug in 2, the absolute value of 2 is 2. So I go ahead and graph those points. And just like I stated, I'll make a nice V shape, which is really cool. So that's going to be my absolute value function. If I want to go ahead and talk about the slope pattern, we'll look at my right side here. When I do my slope pattern of just the right side, I see that from point to point, I'm going up 1, right 1, and to the next point away from the vertex on the right, I also go up 1, right 1. And I'm going to keep that pattern going And I will just mirror it on the left so that way it makes that V-shaped formation. Last but not least, we got to do the domain and range. All the way left, I have an arrow that's going up and left. So I know it's going to keep going to those negative infinity x values on the left. Over here on the right, I have an arrow that's going up and right. So I know it's going to go to those positive infinity values of x on the right. Remember, you can write it in this notation or your fancy R. For the range, I have starting at 0 and including 0, and going all the way to infinity up at the top of those arrows. Another way to write that is going to be with an inequality instead of our interval notation. Y is greater than or equal to 0. Make sure you have the bracket and the equal to. As a note overall, just to wrap up this video, I'm going to use that square bracket. I'll kind of draw it as well, and we can make a starred note here. Anytime I have a included point, so a point that's included, when I have a less than or equal to, or when I have a greater than or equal to. Every time I'm going to use parentheses, and let's go ahead and use that notation. That's going to be anytime I have a negative infinity, positive infinity, because we're not going to contain those, they're going to keep going on forever, as well as just a less than or just a greater than without an equal to. That's going to happen a lot of times when you have an open circle or you have it getting so close to a point but not touching it.